Ionic compounds are compounds made out of a metal and a nonmetal atom attracted to the oppositely charged ion. In ionic compounds, metal atoms are positively charged, while nonmetals are negatively charged. The charge of an atom depends on the amount of electrons donated, or received, by the atom. If the atom receives electrons, the charge is negative, while if the atom gives electrons, it has a positive charge. So in a compound like BeO, beryllium is positively charged while oxygen is negatively charged. But why do the atoms form ionic compounds? Atoms want to be as stable as possible, which typically happens when an atom has a valence shell with 8 electrons. Noble gases already have 8 valence electrons, so they do not form ionic compounds. Other atoms, however, will react in order to gain 8 valence electrons. Once they have 8 valence electrons, they are known as pseudo-noble gases. Determining charge. Because ionic compounds form to give atoms full valence shells, it is easy to predict the charge. Just look at the valence shell of the atoms before they form ions by giving or taking electrons. Atoms are very impatient, so they find the easiest way to get their number of valence electrons to be 8. In the case of metals, they will discard the valence electrons in the outer shell so that the full shell below is now a full valence shell. In this case, sodium, with 1 valence electron, will donate an electron so that it now has 8 valence electrons. Meanwhile, nonmetals will accept electrons because it is easier to accept a smaller amount of electrons than to get rid of their fuller valence shell when compared to metals. So in this example, chlorine with 7 valence electrons will take an electron for a full valence shell. An easy way to remember the charge of an atom is by its place on the periodic table. Alkali metals have a 1+ charge, alkaline earth metals have a 2+ charge, the boron group metals have 3+, the nitrogen group metals have 3-, the oxygen group nonmetals have 2-, and halogens have 1-, with noble gases having no charge. This works for most atoms, but transition metals can behave strangely, and the number of electrons they donate cannot be determined based on their placement on the periodic table. This is due to the fact that they can take up multiple charges. For example, germanium and tin can be 2+ or 4+ charged. Another way to determine the charge is by looking at the compound. FeCl2, for example, has a transition metal iron in it. To find the charge, look at the number of each type of atom. Ionic compounds tend to bond so that there are 8 valence electrons, so assume that the atoms satisfy the octet rule. Since there are 2 chlorine atoms bonded to the iron must have double the charge as the chlorine. Since the chlorine has a charge of 1-, the iron must have a charge of 2+. Another way to see the charge is the drag and drop method. Simply take the subscripts and place them as a superscript of the other atom, then add the charge. Naming ionic compounds with transition metals. When naming ionic compounds with transition metals, a name such as iron oxide could refer to multiple compounds. So in order to distinguish whether or not the name refers to FeO or Fe2O3, we need to add the charge of the transition metal to its name. This is done with Roman numerals and is added after the transition metal, but before the anion. So if we're talking about Fe2O3, then it's iron 3 oxide, while FeO is iron 2 oxide. While you can use the chemical formula to find the name, you can also use the name to find the chemical formula. For example, platinum 2 oxide. That shows the charge of the transition metal. In this case, platinum has a charge of 2+. Since platinum has a charge of 2+, and oxygen, according to the periodic table, has a charge of 2-, the chemical formula is PTO.